Hello, this is Mr. Henry, and welcome to lesson 1.2 Real World Problems Using Square and Cube Roots. This lesson is thrown in here in Module 1 or Chapter 1 because it is an extension of exponents using squares, cubes, square roots, and cube roots. So the essential question says, how do I use square roots and cube roots to solve equations? Which we've actually already done before back in Module 1. We did a couple of these. So this may be a little familiar and not so hard. Did you know games like QWOP, Doodle Jump, Temple Run, and many more calculate how far you traveled from the beginning of the level? And the way they do this is they need to use a square root to find your distance. So they record where you are at the beginning of the level here. And then if you're playing like QWOP, where you have to, your little man, you have to make him run a certain distance, and they record how far it is you got in the end, this far, and then to find a distance, they actually use this little formula, or Doodle Jump. Figure out from the bottom of the map, when you start jumping up and up and up, how far you got to the top. That's how far you've traveled. And they use this formula. Again, that's the distance formula, which will come in handy way down the line in chapter 7, 8, 9, something like that. Way down the line, talking about Pythagorean Theorem. But it does involve square roots. So here we have two vocab words, which we should kind of already know. We have a square root, which is used to unsquare a number that has been squared, like x squared. And it always results in two answers. If you remember from previous lessons, so the square root of 9 always gives you two answers, like a positive 3 and a negative 3. And we usually write that, or sometimes write that as plus minus 3, positive, negative 3. A cube root is used to uncube a number, and the numbers usually look like this, x cubed, and it will always result in one answer. So I have a little table here, which is very similar to the table we used in the past to identify perfect squares and perfect cubes, because it'll be very helpful if we had this table filled out so that we don't have to keep doing it by hand every time. And a reminder that if you're doing your homework or test or quiz and you don't have this table handy, you can always make one very easily. All you do is you list numbers from like 1 to 12 or so, and you list the perfect square. So you take 1 squared, you take that number, and you square it. Take it times by itself. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 16. 25, 36, 49, 64, 81, 100, 121, and 144. To find perfect cubes, you take whatever that number is, and you cube it. You take it by itself, you take it times itself 3 times. So 1 times 1 times 1, 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27, 64, 25, 216. And honestly, you don't need to know the rest of these. I know a couple more off the top of my head. I know that's 343, 512, 729, 1,000, I think. But you don't really need to know those. Maybe you want to keep some of those numbers in your head, just, hey, that number looks familiar. That might be a perfect cube. But other than that, it's just for the perfect cubes, it's up to about, well, 150 or so, 200 or so. So the first few here is we're just going to solve some square roots, which is familiar because we've done this once before. It might have seemed hard before, so hopefully it seems easier now if you remember a little bit. So the way we're going to solve this perfect square, or this square root here, is we're going to unsquare the variable. This is x squared, so to unsquare it, we take, try that again. We take the square root of side. So the square root of this side, remember this out front here has a little imaginary, or not imaginary, a little hidden 2. And so this square root and this exponent of 2 cancel out, leaving us just x. On the other side, when we take the square root of 16, you can use your calculator or the table we made. I'll be honest, the table we made is going to be a whole lot quicker for you. If you take the square root of 16, you should see that the answer is, oops, wrong thing. The square root of 16 is 4. 16 is a perfect square. So the square root of 16 is 4. And remember that it is a positive and a negative. So I'm going to try to keep that plus minus here. Just as a reminder, it's both positive and negative, although a lot of the times we ignore the negative exists. We kind of forget about it, but it is always there. Letter B. When we solve this, before we can take the square root of this, which we'd like to do to get rid of that exponent, we have to get rid of this 3 out front. So in order to do that, since this is a multiply by 3, we are going to divide by 3 on both sides. Because that's the opposite. The opposite of multiplying is dividing. And when we divide by 3 on both sides, these guys cancel out. So we have m squared equals on this side. 27 divided by 3 is 9. Now, when we finish solving our problem here, to square root both sides, square root and exponent cancel, m equals the square root of 9 is 3. I was going to pull up the table, but you guys have the table on your paper. You can see square root of 9 is 3. It is. 9 is a perfect square. The square root is 3. And reminder, it is both a positive and a negative 3. Okay, here are 2 for you to try on your own. When you're ready to continue, hit play, and we will go through it together. All right, so the first one, there's nothing next to the x squared that we have to get rid of first, so we can just start straight out by square rooting. Square root both sides. This x squared and the square root cancel, so we get just x equals. On the other side, when we take the square root of 36, we get just 6. Letter D. Before we can square root both sides, we have to get rid of the 9 out front. So the way we're going to get rid of that 9 out front is by dividing by 9. Because this 9 is multiply, the opposite of multiply is divide on both sides. So you get j squared equals whatever 225 divided by 9 is. I don't know. Okay, 225 divided by 9 is 25. So this side gives me 25 after my square root, or I'm sorry, after my dividing by 9. And now to solve here, if I square root both sides to cancel out the j squared. The opposite of squaring is square root. So then j equals 5. And there we are. We have solved equations using square root. Now we're going to make them a little bit more complicated, a little bit harder here. So now here I have my r squared, my variable that's squared, is being added by 3. So I'd like to be able to get rid of that plus 3 first. And then after I got rid of the plus 3, then we can square root to get rid of the squared. So to get rid of the plus 3 first, the first thing I'm going to do is subtract 3. Because subtracting 3 is the opposite of adding 3. Those two pieces are opposites now, and they cancel. Reminder that you always have to do everything to both sides. So if you subtract 3 on the left, you have to do it on the right. And so now we have r squared equals 7 minus 3 is 4. And then finally, to get rid of the r squared, to unsquare this, we're going to square root both sides, and we get r equals 2. Square root of 4 is 2. Now, a reminder, you could always check your answer for these problems by plugging in the answer you got back into the original problem and see if it works out. So in this case, 2 squared plus 3 equals 7. Well, check it. Does it actually work out? Does 2 squared plus 3 equals 7? And it should be true. 2 squared is 4 plus 3 equals 7. And yeah, 4 plus 3 is 7. So this does work out, which means this is the solution. All right. Letter F, we have r squared equals 64 over 25. So what we'd like to do when we square root this, boom, boom. If you're doing this in your head without a calculator, then, which I'll be honest, I don't think I've used a calculator on hardly any of these problems so far. Most of them I've done in my head. If you know your perfect squares, or if you have your perfect squares listed on a table, it's honestly quite a bit easier and simpler and quicker to just go in your head. I'm square rooting both sides here. This side, I get just r equals. This side, you do not want to divide that and then square root it, because you're going to get a big ugly decimal and it's going to be a pain in the butt. What would be much easier is if we would, and this is correct by the way, square root the top and square root the bottom. Treat it as two separate problems. If I square root just the top, the square root of 64, according to our table, is 8. If I square root the bottom, according to our table, is 5. So my value of r is 8/5. Yes, it's okay to get a decimal for, I'm sorry, a fraction for an answer, or a decimal. This guy as a decimal would be 1.325 or something. 8 divided by 1.6. Okay? It's okay to get a decimal for an answer. It's okay to get a fraction for an answer. Reminder though, when you take the square root of something, you do get both a positive and a negative answer. This is both positive 8/5 and negative 8/5. And the reason why, it'll be easier to see in this example. If I would throw a negative 2 in here, this actually still works out, because negative 2 squared, negative 2 times negative 2 is positive 4 plus 3 equals 7. Yes, it does. So both a positive 2 and a negative 2 work in this problem. And that will be true for all of these problems that we're doing square roots on. Okay, so I'm reminding you, and I forgot here, so I made sure to throw it in. It's both positive 2 and negative 2. So for the next two problems, letters G and H, if you could please try them on your own, pause the video, and then when you're ready to continue, or if you get stuck and you need a little help, hit play, and we'll go through them together. All right, so for letter G, I'm just going to start by square rooting here. So I'm going to square root both sides. This square root and this squared cancel out, so I get just y equals. On the other side, when I square root 4/9, since I don't know what the square root of 4/9 is off the top of my head, I'm going to try to break this down into just the square root of 4 and the square root of 9. Now, I can see by looking at my table that both 4 and 9 are perfect squares, which means when I take the square root of them, when I take the square root of them, the square root of 4 was 2, the square root of 9 was 3, and so I get an answer of both positive and negative 2/3. It's positive 2/3, it's negative 2/3. If you want to write it like that instead of putting the plus and minus in front, you can do that, but it is both positive and negative. Letter H. Before we can solve that, before we can get the p squared by itself, I would like to have this, and then my next step is I'd like to have that. In order to do that, I have to get rid of this minus 4. I'm going to add 4 to both sides to cancel this out. Now we can square root here. These can the square root and the square root cancel. And on this side, the square root of 49 is both a positive and a negative 7. So as we are solving, we try to get the exponent piece by itself first. After we get the exponent piece by itself, then we either square root, or you'll see in a second, we can also cube root to get the variable completely by itself. So a little quick summary question here. What are the two square roots of the number 169? Now that's not on our table, so you may need to use your calculator for that, but what are the two square roots of 169? Pause the video, take just a second or two, see if you can answer that, and then we'll get back together in just a second. Alright, so you might have found that the two square roots of 169 are both a positive 13 and a negative 13. If you calculated second square root of 169 equals, the calculator says 13. It is both positive 13 and negative 13, because negative 13 times negative 13 is a positive 169. Okay, so one of the key things I'm trying to help you remember is that a square root gives you two answers, a positive and a negative. I'm reinforcing that quite a bit. Now, cube roots. When you take the cube root of a number, you only get one answer. So when I cube root here, the cubed root of this, because I needed to use a cube root to cancel out this y cubed. And when I cube root the other side, see what you get. So y cubed and cube root cancel. Y equals. On this other side, when I cube root 27, I get just 3. It's not positive and negative 3, because if I take, well, this case, 3 times 3 times 3 is 27. If I use negative 3, negative 3 times negative 3 times by negative 3 is not 27. Negative 3 times negative 3 times negative 3 is negative 27. It does not work out. So when you cube root, you do not get two answers. You only get. And I'll tell you just a little hint that the sign of your answer will be the sign of the thing you cube rooted. So you can actually take the cube root of negative 27, and it'll give you negative 3. Letter B. So here I have t cubed equals 1/8, so I'm going to cube root both sides. The cube rooting and the cubed cancel each other out, so I have just t equals. And on the other side, the cube root of 1/8. So I'm going to do the same trick I did with the square roots. I'm going to cube root the top. I'm going to cube root the bottom, because I don't know what the cube root of 1/8 is. And so I can actually kind of think of them as two separate pieces. Now the cube root of 1 is 1. 1 times 1 times 1 is 1. The cube root of 8 is 2. Check out our table. 8 is a perfect cube. Cubed root of 8 is 2. So when I took the cubed root of 1/8, I got 1/2. Calculator. 3 second special root, caret. The cube root of 1 fraction 8 in parentheses is 1/2. Now that's 1/2 as a decimal. Mine 1/2 is as a fraction, but it's still 1/2. Come on. There we go. All right. I would like you to please do letters C and D right now. So pause the video, try these two on your own. When you're ready to continue, hit play, and we'll go through them together. All right, so hopefully in letter C, you started by dividing both sides by 2. You had to get the w cubed by itself first. So by dividing by 2, you cancel these 2's out. And over here, you get 8. And then when you cubed root both sides, These cancel, and w equals 2. And you can verify and check your answer. If you plugged in 2 back in the original problem, 2 times 2 cubed should equal 16. Well, 2 cubed is 8. 8 times by 2 is 16. It works. Letter D here. So we would like to start by getting rid of this minus 6. If we can get rid of this minus 6 by doing plus 6 on both sides, we get a cubed equals negative 5 plus 6 is 1. And then to get rid of the a cubed, if we cube root both sides, we get just a equals 1. The cube root of 1 is 1. The square root of 1 is 1. Looks like we got 4 more examples just to help us reinforce the skills here. So letter E, we have the cube, or c cubed equals 216. To get rid of a cubed, I'm going to cube root on both sides. Get c equals 6. I'm using my brain. I know the table. 216 is a perfect cube. The cube root of it is 6. Here, letter F. Before I can cube root, I've got to get rid of this 4 out front. That 4 is going to be a problem. So since that is a multiply by 4, I'm going to divide by 4 on both sides and get b cubed equals. So let's just double check here. 500 divided by 4 equals 125. Okay. So now that I have the b cubed by itself, I can cube root both sides. So if I cube root here, these cancel out, and b equals the cube root of 125 is 5. 125 is a perfect cube, which means I get 5 answer. Here are 2 for you to try. These are letters G and H. So go ahead and copy the problems down. Pause the video, try them out on your own. When you're ready to continue, hit play, and we will go through them together. All right, so both of these problems are actually solved pretty much identically. You're going to start by cube rooting both sides. I'll do this one first. All right, so you cube root both sides. Now here you get just k equals. On the other side, when you cube root both pieces separately, because we have an ugly fraction, 64 over 216, it's much easier if we break it down into 2 simpler pieces. So the cube root of 64, look at your table, is 4. The cube root of 216, if you look at your table, is 6. The last thing we'd need to do is just kind of simplify the fraction. 4/6 does simplify. 4 fraction 6 2/3. So k equals 2/3. If you took 2/3 and you raised it to the 3rd power, if you cubed 2/3, you would get 64 over 216. Or at least an equivalent fraction. Letter H. Cube root both sides. Boom, boom, boom. Boom, boom, boom. Here we got the cube root and the cube cancel, so you have just m equals. On the other side, the cube root of this. So again, cube root the top, cube root the bottom. The top is just going to be 1. The cube root of 1 is 1. On the bottom, the cube root of 729. Maybe you don't know that. So you calculate 3 second special root 720 equals 9. And you can check if that simplifies. It will not, but maybe you don't know that. 1 fraction 9 equals 1/9. Calculator closed pretty quickly there, but yeah, it does not simplify. 1/9 stays 1. So that's how you solve the equation. You get the exponent piece by itself first, then you use either square root or cube root to unsquare or uncube whatever's happening to the variable. Okay, we got a couple little problem solving here. Example 3a says the volume of a cube can be found using the formula v equals s cubed, where s is the length of a side. We've talked about this before. We had cubes in the past. And to find the volume of the cube, it's v equals s cubed, where s is the length of the side. If the volume of a cube is this big, 343, what is the length of one side? Okay, so it's telling us that the volume of this cube, I'm just writing down the formula again. The volume is 343. And they want us to find how big is the length of each side. Well, check this out. Look at my formula. I plugged in what I know. Now it's almost exactly like the previous problems we were doing. It's s cubed equals something. So if I cube root both sides, these cancel, and we get just s equals the cube root of 343. Maybe you don't know it. 3 second caret to get your special root of 343 equals 7. So s equals 7. The length of each side is 7. Letter B, one for you. Now, you don't have to write down the whole problem. Don't worry about all that. You just have to do the problem. So it says here, Sam and Allison are both trying to find the side length of a square that has an area of 100. So Sam's method is to take the area and divide by 4 to get a side length of 25. Allison's method is to take the area of the square and square root it to get a side length of 10. Your job is to determine whose method is correct and explain why the wrong method is wrong. So go ahead and pause the video, see if you can determine who got it right, who got it wrong, and help the person who's wrong explain why it is wrong. So hopefully you saw that Allison is correct and Sam is wrong. So why is Sam wrong? So Sam's method was to take the area and divide by 4. Well, I don't think that works out. So, for example, here's a square with an area of 100. If you take the area and divide by 4, and it said he got each side was 25. Well, if you try to find the area from these numbers, the area formula for a square is length times width. If you take 25 times by 25, you do not get 100. It doesn't work out. 25 times by 25 is 625. So the math doesn't work out. And it won't work out hardly ever. There might be in a case or two, like if the area is 1, you take 1 times 1 is 1. It might work out in that case. But it'll hardly ever work out. So that is explaining why Sam is wrong. Allison's method would always work. If you take the area of the square and you square root it, she got 10. Length times width, 10 times 10 is 100. That would work. And if you tried some other square with some other area, and you try this out, it would also work. It will always work. Letter C. The side lengths of a square are x cubed feet long. Okay, so I already feel like I need to draw a picture here. So here's a square. And it says the lengths of the sides are x cubed feet long. All of them. The formula to find the area of a square is that's true. Area equals s squared, where s is the length of a side. Write a simplified variable expression for the area of the square. So here's what they mean. we need a variable expression that has been simplified. That's what a simplified variable expression is. So my answer is still going to have variables. So let's just figure out what we can do. So from this information here, if I plug in the length of my side in for S, I would get this. S is x. Oopsie. I realize now that this is supposed to be a squared. I typoed that wrong. So I'd have x cubed for S, and that whole thing is squared. So if we simplify this variable expression, that will give us a simplified variable expression for the area of the square. Okay, so we got to dig back into our memory banks from the previous really long lesson on what do you do if you have a power raised to a power. You multiply the exponents. You distribute the exponents. So this becomes now then x to the 6th power. And that's done. I can't really simplify that anymore. So the area of this square would be x to the 6th power. Whatever x is, if I raise that number to the 6th power, that would be the area of the square. Okay, so letter D here. It says the volume of a cube can be found using the volume of S cubed. Cube A has side lengths of 5 squared, and cube B has side lengths of 3 cubed. They would like us to write the ratio of the volume of cube A to cube B. If you remember, a ratio is a lot of times written as a fraction. Okay, so there's my hint for you. So go ahead and pause the video. Try this problem on your own right now. When you're ready to continue, hit play, and we'll go through it together. All right, so my formula, B equals S cubed. And it says the final goal is to write a ratio of the volume of cube A to volume of cube B. So if I can find out what the volume of cube A is and the volume of cube B is, then I'd be done. So I'm going to use this formula. I'm going to find the volume of both. So I'm going to start with the volume of cube A, and then I'm going to find the volume of cube B, and plug it into my little formula over here, and I'll be good to go. The volume of A is, it told me that the side length of cube A has side lengths of 5 squared. It told me that cube B has side lengths of 3 cubed. And I want to know which of these is bigger. Or actually, I don't care which one's bigger. I just need to write it as a ratio. So then, volume of cube A, if I simplify this math, I would multiply my exponents. Volume of cube A is 5 to the 4th power. Volume of cube B is, multiply my exponents, 3 to the 9th power. And I'm done. I mean, it doesn't say that I need to write a simplified variable expression where I'd actually or evaluate this thing to get a decimal. As far as I'm concerned, I'm done. I don't really have to do more. Now, if you chose to do more, or if you did another step and you tried to like find this answer and find this answer and divide it to get a decimal, hey, more power to you. But we didn't have to go that far. We were just trying to write a ratio of the volume of cube A to the volume of cube B. And we did that. Okay. Example 4 says, what is the solution to this equation? Okay. So we could actually solve this a couple different ways. You could solve this by solving the equation like we've normally done. You could solve this by using some guess and check. I mean, try this out. Just imagine guess and check. If you plugged in 6 here and you typed into your calculator, is 4 times by 6 to the 3rd power, 6 cubed, does that equal 864? Oh, sorry. In that case, yeah, it looks like it does. It looks like letter A is my answer. So my guess and check method solved it in One guess. Sometimes you get lucky, sometimes you don't. Now, what if you didn't use guess and check? If you solve this by hand? Well, what you would do is you would take this guy here. I'm just going to move forward. And you would solve like we solved the other ones. You would, first off, get rid of this multiply by 4 out front. So you would divide by 4 on both sides. E cubed equals whatever that equals. 864 divided by 4 equals 216. Now, to uncube b cubed, we would cube root both sides. This cancels. B equals the cube root of 216 is 6. We saw that in our table quite a bit back in the lesson, wherever he is, way up here, cab box area. 216 is a perfect cube, and the cube root is 6. You could also do that just by, throw it into your calculator. Where 3 second caret, that gives us our special root, or in this case it's a cube root, of 216 is 6. Okay, if we tried all these other ones, none of them would work out. There's only going to be one solution here. So I'm just going to try one just to show what would happen if we plugged in, say, the 2. Well, 4 times 2 cubed equals 864. 2 cubed is 8. 4 times 8. 4 times 8 is 32, not 864. So this does not work out. It is not equal. And none of the other ones would be equal either. Summary. So when solving an equation with an exponent, what should you check for or do first before you square root or cube root? You can answer that question on your own. This has been lesson 1.2. Thank you for watching.